Okay, so today is kind of a review of what we already did with chords, and we're talking about a circle or two congruent circles, and it has two minor arcs. Remember, these are the arcs that are smaller. We'll talk about that more when I get back. But if two arcs are congruent, if and only if their corresponding chords are congruent. So these arcs are congruent, arc AB and arc CD, and they're congruent because AB is congruent to CD, the two chords. Then it talks about a diameter and how the diameter is really a perpendicular bisector to the chord. It forms a right angle and these two sides are congruent. And then it talks about the opposite. If in a circle you have a perpendicular bisector to a chord, it does contain automatically the center of the circle. So now we're going to work a couple of problems that just kind of build on the things we learned yesterday. One more piece though, in a circle, or in two congruent circles, two chords are congruent if and only if the distance from the center of the circle to the chord are equal. So in this example, I would say if this was for this distance from M to the chord, and this was for, you could say that these two chords, AB is congruent to chord DC. Okay? So those are some of the rules we're going to apply as we work a few example problems. So the first example problem we're going to do is example 1, where it says OD is 15. And it says that CD is 24. So this whole thing is 24. We know this bisects it, so this has to be 12 and this has to be 12. And so then it's asking us to find OE. And then it's asking us to find EG. Okay? So you're going to start with your right angle. Okay, right triangle. And if this is 15 and this is 12, we should be able to find OE, right? So it's 15 squared. 15 squared is equal to 12 squared plus x squared, or 225 is equal to 144 plus x squared, or 225 minus 144 is equal to x squared, and x is equal to the square root of 225 minus 144, which second square root 225 minus 144 gives you 9. So x is equal to 9. So we found side OE, and we know it's equal to 9. So now if OE is equal to 9, and we know OG has to equal OD because they're both radiuses, and OD is 15, then OG is 15, then EG has to be equal to OG minus 9, or 15 minus 9, which is 6. So EG is equal to 6. So that gives you a little bit that you can work from as you work some of these problems. I'll work example number 2 also. At the bottom of the page, it says the measure of MQ, this arc, is 120 degrees. And whatever this arc measure is, it's the same as the central angle measure, so that's 120 degrees. And it wants you to find the measure of NP. this arc over here. Okay? So we know that each of these chords, it says MN, MP, and PQ are all equal. So if I call these angles, so their central angles would have to be equal too. So if I call each of them X, I know that X plus X plus X plus 120 degrees, right, because I'm going full circle, has to equal 360 degrees. So if I subtract 120 from both sides, I get 3x has to equal 240, or x has to equal 80. So x would be equal to 80 degrees. So the measure of NP, the arc there, would be 80 degrees.